Okay. Oh, now I can hear me. Well, welcome. Good morning. I'm glad you're all here and awake. I had not enough food and too much wine last night, so the morning was questionable. But we're all here. So, as Enno said, I'm Justin Lee. I work for Red Hat on the Quarkus team. Anyone heard of Quarkus? Oh, fantastic. Normally it's like, it's 3 or 4. Anyways, we're not going to talk about Quarkus. That's not what we're here for. But we'll mention it here and there. So we're going to talk about code generation. How many of you actively use code generation now? Yeah, okay. I'm talking to a group of experts. Fantastic. Okay, so, sorry. My head's too big for these. Oh, forgot one vital piece. The dongle. There. So the title, you may notice it's not exactly proper English, or you may not, which is fine. But it's an homage to this book. Anyone read this? Any Haskell types in the room? It's a classic. I haven't read it, but I love the title. So I stole it. So, all right, so my entire career, I've had all my friends tell me that code generation is terrible, you should never do it, blah, blah, blah. And I've never quite understood it, but here's some of the reasons why you might think it's bad. It's clunky to work with. I think we've all been there. This is very, very true. It can be hard to update, which is absolutely true if you're not careful. And it generates terrible code, which is also really true. I was doing a demo years back of a web framework, which I'll not name, because they're lovely people. But it was just a simple, like a prototype. I just needed like an input box on an HTML page and a button, right? Not complicated stuff. But the generated code had like 9 or 10 levels deep of nested divs for whatever reason. I couldn't figure it out. I mean, it worked, but it was just terrible. So, but why do I love it? So, in the early 2000s, just after Y2K, it's mostly, okay. I was afraid the audience would be too young. But yeah, so I was working for a financial systems company in Denver, Colorado, and we had a business model. Now, the system was designed for, like, you go to the bank and you want to open up a checking account, or you want to get a loan and you offer collateral. All this stuff has varying requirements depending on what state you're in the United States. And then, of course, there's federal requirements. So this model was managed by lawyers because they knew what they were talking about. And they did it in rational rows, okay? So that should set the tone for the rest of it. And there were hundreds of entities. I mean, there was everything. There was a boat in California or a boat in Wyoming. It was all like these nuanced of stuff. It was insanely, insanely complex. We'd print out the diagram and it would literally take the entire wall and we'd have to like step back and look at it because it's like a mosaic. If you get too close, you see like the individual pixels. It was enormous and it was a lot to handle. And of course it would change because lawyers or the legislature is always changing a law, right? So the model would change frequently either because of new laws or the lawyer would figure out like, oh, we didn't get that right. So they would tweak it. But we had all this Java code modeling this, right? Because we need to run code eventually. And so keeping those two in sync was very complicated. Unless you do the obvious thing and you generate the Java code from the UML model. So the UML model was exported out of rational rows via Visual Basic script to an XML file. It was technically XML, but yeah, it was gnarly. So this is pre-EE1, Java EE 1.0 days. We were using JSPs, but it wasn't like the final version of the spec, so it's somewhere around 0.9.2. So there weren't a lot of off-the-shelf solutions, like Hibernate didn't exist yet, for example. So we built a lot of our own stuff. And someone, before I had gotten to the company, had built Bob, the business object builder. I love puns, and so that one I always enjoyed. So Bob consisted of hundreds of code snippets, and they were each in their own file, right? And so it was very hard to see, like you'd look at this template, I don't know what this does because it lacks context, right? So I rewrote it because it was very difficult to debug. And I wrote it in XSLT. It was 2003, so stop judging. It was the height of technology then. However, oh yeah, and his name was Joe, because I said I like puns, the Java object emitter. And it was its own version of hell. Does anyone remember XSLT? Yeah. You could see the code in context, mostly, but there's all the angle brackets and everything around it. It worked, but yeah, it was definitely better than what came before. And yeah, we used it to great effect. We had a bug at one point, so we had many-to-many relationships, and the way the code worked is if you saved A, it would go and save B, and B had a reference to A, so it would go and save A. But you want to do like a cycle detection, otherwise you just sit there forever saving the same two objects. There was a bug there, and then I fixed the template, pushed it out, and then across hundreds of entities, bam, fixed with one commit. Except it was CVS, so if you remember CVS, each file had its own revision, so it's technically hundreds of commits, but it was one push of the enter button at least. So all in all, we had 1,500 classes managed this way, and it was as nice as it could be to be managing a model size that big. And I've loved it ever since. It was so, I was the masochist who volunteered to maintain that, and I've been doing it ever since, and I love it. So some benefits. Multiple language support, so you can generate from your model. If you have multiple clients, for example, you can generate different programming languages, or even spoken languages, I suppose, in certain situations. Adding a new language becomes trivial, and I put that in sarcastic quotes, because it's just adding a new generator, right? And sometimes it's a library that's already written, and sometimes you have to make your own. So, but the real benefit is you get consistency across, multiple languages, across subsystems and such. More specifically, you get consistent method definitions, or you can, if you pay attention. So if you have like a particular pattern for naming your methods, you can make sure that all the methods work that way because you generate them, and you can see when something is out of spec. Same with your parameters. And also ordering, right? You wouldn't think ordering matters, but it's one of those like little mental speed bumps that makes it slightly more awkward to work with your API for users. In my own API, I discovered the other day, I had 2 overloaded methods where the parameters were in different order, but I didn't notice it until I went to fix a bug. But now I'm stuck with it because it's in user code. You can generate documentation straight into your code, so you can centralize your documentation in your model file, and then you can generate your Java doc or your Docker or RDoc, I think Ruby uses, whatever it is. But you can generate it all with your code, and it's all right in your model. And like I said, you can do mass bug fixing all at once because you just regenerate it and the bug goes away, right? Nice and easy. Some of the dangers, however, you can generate mass bugs all at once, and this is super easy, because when you're generating code, it's generally like uniform, but sometimes there's some nuances and you try to get tricky, and you don't quite get it right. It's fragile, so if your specs change for whatever reason and your template isn't quite expressive enough to follow along, it can be hard to manage. And it can be quite complicated depending on what your build cycle is. Like, you have to be really aware of what you're doing, or you find yourself in weird build cycles and dependencies and such. And you might end up with a low beer truck factor. Has anyone heard that term? There's a couple of milk truck factor, bread truck, whatever. The idea is this. In my case, like, I was the only guy working on Joe, working hard all morning long. Lunchtime comes along. I go out to have lunch. I get hit by a beer truck and I'm dead, or in the hospital. Now no one knows how to fix this code, right? Because no one else wants to touch it. So it's important to get buy-in from more than just one person, because even vacations happen, right, sometimes. So for the polyglots, as I said, onboarding a new language is easy, but you should be careful about it because you're adding, it's not just an output target, but it's a whole ecosystem and a separate set of concerns that particular user base, like the JavaScript people, care about different things than Java people do. So you have to be able to address both of those out of one model and template. And differing capabilities. When I worked at MongoDB, I started early on, and every driver, so the C driver, the PHP, the Java C#. We all had our own ways of doing things, which was fine because in our own little teams, we just did what we wanted, and it was fine. But when we tried to unify it so that as users, if you switch from the C# to the Java driver, there's familiar nomenclature and workflows and everything. The interesting thing we ran into is there were certain things that we were just designing into our spec that wouldn't work for, say, like PHP, because there's no threads in PHP, at least at the time. I think it's still true. No persistent state across requests got really complicated. And those are things we just took for granted in the Java and C#. But once we started to try to make things consistent, we ran into some hiccups. All right, so some examples of code generation that you're probably already using, and you might not realize it. We have, there. gRPC is the new Corba. I will die on that hill. It's actually quite popular and quite nice, but still. WSDL and SOAP, anyone still using either of those? Are you in financial institutions using those? That'd be my guess. It's fine, it's just older. OpenAPI or Swagger, anyone using that? That is amazing stuff. Quarkus supports it, by the way. Mapstruct is also a way to generate entities in the Java world. I don't know if they have other languages. Lombok, anyone use Lombok? That's bytecode generation at compile time. Shouldn't be using it though, it's bad for your health. There's a project, how many of you use Jackson, the JSON parsing library? There's a project called Afterburner where he will generate the code to serialize and deserialize your JSON objects in and out of your entities, so you don't have to do reflection at runtime. It's quite nice. And I loved it so much, I added it to my own project, which we won't get into necessarily, although my own project is the inspiration for part of this. If you go, that's a like Hibernate from MongoDB, if you're in either of those worlds. It's amazing, but the website is not the prettiest. And also Quarkus.io. I've been doing Java since '96, and I managed to not really concern myself with bytecode until, I don't know, 4 years ago or so when I joined the Quarkus team, where we do all sorts of crazy bytecode stuff at build time. And it's fascinating, but you know, it's a bullet I dodged for years until I got thrown in. So what we're going to look at is we're going to look at a couple of options for generating source code and some options for generating bytecode and talk about some options for either. And I remembered this time to change my theme so that it was not the dark. Is that readable in the back? I remembered to fix the fonts as well. I usually forget until I'm up here and then I'm thrashing. Okay, so here's how this is going to work. We have 5 different generators we're going to look at, and we're going to run the exact same test every single time. Now, you might notice that hello world is in red because it's not there yet. No declaration. So we're going to generate that as part of our build. So the first one we're going to look at is source code generation, which I tend to prefer because there's nothing more frustrating than getting a stack trace and you click on it in your IDE and it takes you off into the middle of a decompiled class file. It's sort of helpful, but not entirely. I like being able to get into the source code and tweak things if need be. So we're going to look at 2, and we're going to do them side by side because it gets a little tedious to go through one and then the other because they're very similar. So let me do split and move right. We're going to get rid of the test for a while. Okay, so the first one is called Java Poet. It's from Square. If you're familiar with Square, the payment services company, if you do Android stuff, you've probably used some Square libraries. So they have one called Java Poet, which I actually use in my Morphia project because they also have one called Kotlin Poet. And spoiler alert, that one generates Kotlin instead of Java. But the APIs are similar. And ironically, between those 2 APIs, they have very similar APIs, except they swap the order of certain parameters. So it makes it very difficult and annoying to maintain both, but whatever. So anyways, that is Roaster, Java Poet. The other one is Roaster. It comes from the JBoss Forge project from ages ago. We still use it a fair bit here and there. Yeah, so we'll look at it and see. Depending on what you're doing, it can be nicer to use one or the other. Now, there is a little bit of ceremony around this that if you want to go look at it, you can, but we're just kind of sort of ignore it. There's some Maven plugin stuff that's in here, but only serves to get me from my Maven Mojo into the generator. We can talk about it, but it's not entirely on topic here. So let's scooch this out. So with Java Poet, you start off with the type spec, and we're going to create a class. We're going to add modifiers. In this case, it's going to be public, because the default in Java is package private. We're going to add some annotations just because we can. I don't know if it even makes sense to use that annotation there, but I wanted to pick one that was simple enough to do. And then you can also add an annotation by classname.get, and classname is I think it's a Java Poet API. They do some nice things for parsing class names. But anyways, this one takes parameters. So you can see here, we're going to add the value. Every annotation has the value field on it. We're going to give it a value, and we're going to give it the message, all of it, and then we're going to add it. Right, so to see that in roaster, before we get, where are you going? That was weird. So roaster looks kind of similar. Here. So we're going to create as a static method, which I've imported. So we're going to create, we're going to give it the type we're going to create it, Java class source. There's a number of different cases in there. We're going to give it the same name that we gave the other one, hello world, and we're going to give it a package. Antworks is my own domain, whatever. With roaster, you have to manually add imports, or you can at least. Both of them do their best when they detect a type to automatically add it to your imports for you, so you don't necessarily have to manage the imports, but there's a few cases I've run into where if I didn't manually add the import, it just never showed up. I don't know if that's a bug or if that's just how that particular piece was supposed to work. And again, we're going to add the same annotations, the enabled from flight recorder and suppress. This API is slightly nicer. There's not a whole lot of indirection and builders on it, and slightly easier to read. So we're also going to add, you can generate Javadoc if you want. In this case, all we're adding is the sense tag, and it's been there since forever. And this is what it looks like in Java Poet. Java Poet uses this idea of a code block kind of everywhere. In my experience, it doesn't make a whole lot of sense to generate like down to the method level. Like if you try to generate source code that has like all your if statements and your whiles and whatnot, your generator gets very tedious very quickly. There might be times when you need to do that, but I've managed to avoid it for the most part. So you can pass in when you're creating which we'll see in a second, when you're adding a method, you can pass in a code block. So you can literally just take, here's a chunk of text that is the source code, just drop it straight into the generated class. So you can kind of bang out large chunks of it all at once. So adding a method, again, Java Poet does builders everywhere. So you can have method builder, you add modifiers. You have to tell it what it returns. I wish it would default some of these, but it doesn't. So you have to be explicit on some of this. And here we're going to add code. So this method called greet, all it's going to do is going to print out the results of calling the greeting. And as you can see here, we just passed in that chunk of code. Could I generate that entire statement via Java Poet? Probably, but it serves no functional purpose to get that down into the nitty-gritty. And then we're also going to add, in this case, an annotation to the method, because we can. In this case, we're going to add the name annotation, and appropriately named Inigo Montoya. Right, so that's adding a method in Java Poet. And then this is a little bit nicer, I think. I don't like the whole code block API thing that Java Poet uses. But this is it's a little easier to look at and see. I know what's going on. There's not a whole lot of types that you have to kind of figure out. The body is straightforward. You can just pass in the string blocks. We're going to add the annotation. We're going to give it the same name annotation with the Inigo Montoya. And here we're going to build the second method. This one's called greeting. It returns, of course, hello world, because that's the first program you always write. And then for Java Poet, it is very similar. So here's greeting. We're going to add the code to return hello world and return a string. And then this stuff down here, all this output, blah, 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 that is, each API has like a slightly different way to output the source. And not to gloss over it, but it looks like that. It's not complicated, but not terribly interested either. So these are 2 ways to generate the source code for these, and we're going to see them in action. So if we come and what I did, because I powered everything by the Maven plugin so that when I want to, I can just run, pass in a flag and change the generator, right? So if we go back to our test code gen, let's put you back over here. We're going to pin you so you don't go away. All right, so it's still red, as you can see, but now we're going to run our Mojo, and we're going to pass in the flag to run the roaster source code. Maven's going to do its thing, a lot of its thing. As you can see, it says build success. So it ran, and you notice over here, now the hello world has an actual declaration to go to. And what that looks like, if we click on over, if you've ever done anything with like resource or whatever generation, with Maven, it ends up in the target directory under generated sources. In this case, my Mojo is named CodeGen, and then it just creates the source tree. So this is the hello world generated by roaster in this case. And as you can see, we have our 2 methods. It's very straightforward. Nothing terribly fancy about it. But that's our generated class. And if we want to compare it with how Java Poet does, we'll run this. When I gave this talk while that's running a couple of months ago, and someone asked, why not just use something like Timeleaf or like, one of the templating things? And the answer is sometimes that's the right answer, right? If you're just generating stuff. In my particular case, and most of my experiences doing it, I needed slightly more complicated conditional stuff. Like I didn't necessarily always generate everything that the template could do for every entity type for various reasons. And if you start putting in conditionals and such inside your templates like that, it starts to get really gnarly and harder to maintain because you've got all this stuff going on. All right, so that was a success. And if we look at the source code, you can see slightly different, but pretty similar. I'm trying to remember, I think Java Poet they will both output formatted source code for you, so it doesn't all up in one line. The format isn't necessarily what you might want, but it's generated, so it's not entirely a big deal. But that's the Java Poet version, and it's straightforward, and it runs from the same test. Now, so that's the generated source code. This example is not terribly complicated, but the fun stuff starts when we get off into bytecode generation. Now there are 3 options we're going to cover. One I leave to the end because it's a little more complicated, and if we run out of time, you're not missing that much. It is surprisingly difficult to work with. So the first one we're going to look at is, it's a project called Gizmo, and I'm trying to remember, it came out of the Quarkus project because we generate a bunch of bytecode as part of the build process. And there is a library which we'll look at next called ASM, which is like the standard bytecode, both parser and writer. But the API for that is awkward. Anyone know the visitor pattern? Yeah. You have a code generator based on the visitor pattern, and it works, but it's weird. So we built something new to wrap around it, if I can find where I'm going here. So we called it Gizmo. I don't know why Gizmo. I'm guessing something from Gremlins. I don't know. Probably not. So this is what it looks like. It is also builder-based in a hopefully slightly nicer way. But it's built on auto-closable, so you can create your creator as part of the try block, and when the try block exits, it'll call close, and the builder will then output all this stuff. We're going to give it a class name. For Gizmo's case, we give it the fully qualified class name, rather than in the other examples, we give it like the class name and then separate package statement. Here we give it the entire thing. This class output, again, is just how Gizmo writes out bytecodes. We can look at it if you like. So we're going to do the exact same thing. We add the enabled annotation, and we're going to add the suppressed warnings. We're going to get rid of all of them. So the greeting method, which just returns the string for hello world. So Gizmo is pretty good about abstracting away the bytecode for the most part, but it helps to know what happens at the bytecode level because it kind of leaks out into the API. So there is, let me just run this and we can look at it simultaneously. So you'll notice this call, where'd you go? Down to, nope, it's in the greeting method here. You notice this call to load. There is a bytecode called LDC, load constant, from like the string pool, and that's what this is doing. So you have to be a little bit more explicit because you're literally writing out the individual instructions in the bytecode. Gizmo hides a lot of that from you, but you still need to kind of understand how a class file is laid out in some ways. All right, so it processed and it ran. If we go back to our test directory, I wish that was collapsed by default. I've been collapsing it for years, and it gets old. All right, so this is our target directory, and you can see there's no more generated sources directory because we're not generating that anymore. But what we did do is we generated straight into the classes directory, which is where Java-C will output a class file. Now, IDEA will actually load a class file for you, but that's not as interesting as it could be. So there's this plugin that I have come to love called the ASM bytecode viewer, and we'll get to that. So if you really want to look at the bytecode, like how it's supposed to look, because IDEA will actually show it you as like a Java source file, and it's not as interesting in those cases. So if we come back here, there's this load. This is what a constructor looks like. It's init. It takes no parameters. It does some stuff. If you want to go through all that, I'm happy to talk to you about it. But this is that load method we just called the LDC that loads the string. So you have to know that's what's happening in the bytecode to tell Gizmo to do that in your generator. And then we return it, and that emits this one line here, the return. What was that? I went for the scroll bar and it just, anyways. So there's this return value load sequence generates these two lines of bytecode. And this is some internal housekeeping for the verifier. So that's a pretty basic, straightforward method. And then now what we're going to do is look at the one where we call it, slightly more complicated, but not terribly so. We're going to greet, give it a return type. Here's where we add the annotation. It's pretty straightforward. In this case, there's an annotation instance builder, and we can add it down here. We make the method public. This looks a lot like the roaster code in a lot of ways at the higher level. But when you get down further, for example, like invoking a method, so we need to get a handle to the method that we just generated. So that's what this part does. We're going to get, this is of method on method descriptor. And we have to tell it which class the method lives on. And then we have to tell it the name of it. And then the way method resolution is done is it includes both the name and the type parameters in the call. And that's how like overloading is done in subclassing and whatnot. So if we look at this method, right, so let's come back here. So we have greeting, and this is actually the return type of the method that we're trying to invoke, and that's what that looks like. This is the internal name for string. Instead of the dots, they use the slashes. Someone once explained why they did that, and I think the short story is historical reasons. But that's how you resolve it. And then once you get the method handle, you can then just invoke virtual method. And again, you have to understand the difference between invoke virtual, invoke static, invoke dynamic, invoke special for constructor calls. Like you have to understand what the bytecode wants at that point to generate it. But then we pass in the method handle that we just found, and then we have to pass in get this, because every method has kind of like an implicit this parameter in the 0th position, if you will. And that's what this aLoad0 does, is it loads the 0 element in the parameter list. And then here we go, we're going to invoke virtual. We're going to call our greeting method, which returns a string. And then we're going to store the return value of that, right? Because we need to keep it around. Now we're going to do get static to get system out. And that looks like over here. So this is off in the weeds, but that's why we're here, right? So now we need to get a field off of something. And again, we tell it which class it lives on. So it's on the system class, of course. It is called out, and it is a print stream. So now we have a reference to the field, but we also now need to get a reference to the method, right? So this is the descriptor for it, and now this tells it to go get that field, and it's a static method, because that is slightly different how that's done. And again, we're going to get the method handle on print stream called print line. It returns nothing and takes a string in our case. And then we're going to invoke virtual on that print line method, and we're going to pass in. This is the owner of the function that we're calling, and then. And that's the parameter that we're going to get. That's the value that we're going to pass for the string. And then, in an absolutely non-obvious way, we want to return void, because every function has to return something at the bytecode. In Java, of course, you just put your curly brace and you go to lunch. But the bytecode always has a return statement at the bottom. So in this case, we have to tell it to do a return, but we're not going to give it anything. So we're going to do a load null, which was not intuitive at all. But what that gives us is this. So here's that get static for the system out. Then we invoke the virtual on the print line, and we're passing in, this is the signature that we're resolving it. And now we have return. And return doesn't do, there's multiple different types of returns depending on what you're doing, reference types versus primitives, for example. This is returning nothing, so there's no type associated with this particular return. If we look at here, you can see this is an A return, which is used for reference types, because we're returning a string off the stack there. I think there's like an I return. I think it's just I return for primitive types. But it might change depending on whether it's float or integer, I don't remember. But all that then generates our class file in Gizmo. And as you can see, when we ran the test, let's close you. As you can see, when we ran our test, it worked just fine, build success. If we look at our test file, it shows that there's the declaration, but of course there's no source for it. It's just the decompiled class file. And that's Gizmo. It's actually really, really nice. I really liked working with Gizmo. Most of my work on the Quarkus stuff has been with ASM, which we'll look at now. So when I started to look at Gizmo to build this particular demo, it's like, why are we doing ASM ever? I'm sure there are reasons, probably historical. So let's take a look at ASM. Now this is where it gets a little gnarly. It's all the visitor pattern, right? So we get a class writer. These are mostly just constants. We're going to tell it what version of bytecode we're going to write. In this case, we're doing 17, and we're going to pass in certain flags. In this case, it's a public class. This is the name without the L and the semicolon for some reason. And then this is various information about the signature. Our class is pretty simple, so we don't have like any interfaces up there. Our super type is object, because we're not explicitly extending something, but every class extends object, except object. And this is for like generic signatures, which we don't have in this case. Right, so we wanted to add that annotation, remember? So we have to visit annotation, because that's how you do. You're going to give it the internal name for that, and not in the other place, because I don't know. And then visible true, you can add annotations to a class file that are available to, say, like the verifier and such, but not necessarily visible to reflective code, right? And there are various reasons you'd want to do this, but that's what the flag for true is telling it to do. And then, of course, once you're done, you call visit end, and now suddenly your class has an annotation. So we have to build a constructor because we're generating bytecode directly. With the source code stuff, we didn't have to bother because the compiler gives you one if you don't declare a constructor, right? So here's our constructor. It's public. There's the init name, like I showed you. So the descriptor is a list of the parameters and the return types. In this case, it takes nothing and returns void, even though constructors don't return anything in the source code. In the bytecode, they do, because every method has to return. It has to unroll the stack, essentially, right, once you're done with that method call. And there's no generic signature and there's no exceptions. The label stuff is some internal housekeeping for the verifier, but it has to be there. The aLoad 0 loads the this, and invoke special is the call to the super call, because every constructor has to call either another constructor on itself or a parent constructor all the way up the tree. And then this visit instruction says to return from our function. And then this just generates some of the housekeeping stuff for the verifier. All right, now the important stuff. So we're going to visit the method to create greet, and you're going to see here, I keep pointing at the screen like you can see it. The descriptor takes no parameters, returns void, because we're just going to print, I believe we're doing this one, yeah. We're going to add the annotation, and again, it's visit annotation, this time on the method visitor that we're using to generate the method, visit end. This visit code is mostly, I've never actually seen it implemented anywhere, but it's part of the API that if you don't call it internally, ASM itself, the state gets off, so I'm not entirely sure. I've never seen it used, so I can't tell you exactly what you might consider doing there. Right, so remember, now we have to go get our field. There's our get static called off to system, Java-Lang system. We're going to get the out field, and it is of type print stream using its internal type. So that's how we get the reference to the field. We're going to aLoad this. This is where we load the this reference, because we're going to call a method on ourselves. So we have to load this onto the stack. Then we're going to visit a method instruction. We're going to invoke virtual against our generated class, which is this. And it's going to be called greeting. And this descriptor, it takes nothing and returns a string. And then isInterface is false. If you're invoking on a method on an interface, it looks slightly different. And then, right, so once that's done, we're going to invoke virtual and call println. This return value out of the invoke virtual to the print stream, when it comes back, it's already on the stack, so we don't have to deal with it. We can just go straight to our next thing to invoke virtual, and then the values on the stack get passed along to that other method call. And again, the labels for some housekeeping stuff. And then this is greeting. More of the same. This is the LDC that we saw before. We're going to give it the string hello world. Stop with the pop-ups. And then we're going to give it, we have to return. So once this load instruction is done, this string constant is on the stack, and then we just do an A return to then return that back to the calling method. So that's what that looks like. And if we run it, it will, of course, pass, because I'm a professional, and I've done this before. Now, one thing I want to say about ASM, it might be, if you decide to go down this road, ASM is likely to be the choice that you use. We don't use Gizmo everywhere for reasons. I have a feeling there's probably some cases that it just doesn't do because we haven't needed it to do that. So I'm not sure. It may not be suitable for a full generate your application sorts of scenarios, but you're almost certainly going to end up in ASM. And this looks daunting, and it was for me when I started, until I discovered this ASM plugin. Now, there is a dirty little secret. Like, you can use this to look at the bytecode, and it's really interesting sometimes, especially if you're doing lambdas and there's weird stuff that happens to the bytecode. But what you probably didn't notice is there's another tab right here that generates, oh, look at that. There's a visit annotation, visit method, and it's literally the code that I just showed you came from this tab, because I was exhausted by the time I got to this point. But it's actually quite clever, because you may want to like generate code, but you're not entirely like, I'm not a bytecode expert. There are things in there that like, I sort of know what it does, but I wouldn't want to like be hired for that little tidbit of knowledge because it's probably wrong. But what you can do is like, if you know what you want your code to do, you can just go write that code, right? Just manually write it to get like this, the scope of it done, compile it, open up this plugin, and then you can literally see like what would it take to write ASM code to generate that bytecode. It won't necessarily get you all the way there, but it got, in my case it did, because my case is simple. But it will get you just tremendous distances down the road, because like some of the interactions, especially with lambdas and things like that, how do you write that bytecode? I don't know. Let the compiler do it for you, and then just kind of figure out like, oh, okay, and then mimic what the compiler does. So you can kind of get, it's the whole like Wizard of Oz, man behind the curtain sort of a moment. It is really super helpful. And I actually use this plugin all the time because I work at the intersection of Quarkus and Kotlin. So it's already like weird bytecode stuff, but then the Kotlin bytecode stuff is slightly different because they do internal housekeeping stuff. This has been invaluable to figure out just what in the world is going on with some of that stuff. So that's ASM, and as promised, it was a success. Okay, so we have 7 minutes. There's one more that I can show you, or we can do questions. Which would you prefer? One more. Yeah. So the irony of this particular project, and I know the developer, so I don't want to like trash on it because it's really good, but it is complicated. So ByteBuddy is a wrapper around ASM. It was designed to make ASM easier to work with, and I think somewhere along the way they got a little too excited about what they were doing, because it's complicated. So here we're going to generate our code. All right, we're going to subclass object. We're going to annotate it with a new functional interface annotation, new enable annotation. Yeah, we're going to define a method. Greeting returns a string. It's public, and this was not obvious. Yeah, when I asked for help on the mailing list, they're like, "Oh yeah, just use an advice as a type in ByteBuddy called an advice. Yeah, just use advice." I don't know what that means, but I finally did get it figured out. It's actually much less code in a lot of ways than the other two, but it is a little less readable unless you're just really into ByteBuddy. I use ByteBuddy for proxy generations, which is amazing. I'm not sure it was really intended to generate classes out of whole cloth the way we're trying to do here. But it's a little bit more straightforward. You can actually use the reflection API to short circuit, like how do you go get the system out print line guy? You just, you get the method, which is, anyone do reflection code at all? Sometimes? This is literally just the reflection Java lang reflect. Get the declared method by name in the parameter list and such. So it does have nice little conveniences for that, so you don't have to worry about like, fetch static, blah, 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 all that stuff. You can just use the reflection API, and that's actually pretty nice. And then we're going to, this tells it to, on this field, go get that guy, and then we're going to invoke a method named greeting. This adds the annotation, and then we dump it out. So it's actually much smaller code, which is sort of nice if you're into that sort of thing. But it is a little less obvious how to get from A to B. And this is just a very simple thing, right? One method is returning a string, the other one is just printing it. I'm not doing complicated stuff. As you get more into it, this code, I think, will look a little less nice than some of the other options are. But Byte Buddy is very powerful and very effective if you need dynamic proxies to, like, Hibernate actually uses, I'm pretty sure it uses Byte Buddy for the dynamic proxies for dirty tracking and that sort of thing. Yeah, so it's a nice one, but it does take some work. And that is that we have, he says 5 minutes, my phone says 4 minutes and 20 seconds. So that is the last of the generator. I'm happy to answer whatever question I know the answer to. Anyone? You were first.
What did you have against Lombok?
And again, like, I know that developer as well, so I try not to trash on too hard. So Lombok does some very nice things. I was working on some test container code yesterday that uses Lombok. And things like sneaky throws, it's actually kind of nice because checked exceptions kind of suck in certain cases. But as far as that goes, Lombok will do things like generate constructors and such for you, which as a developer is nice. As someone who works on a library that analyzes your class definitions and tries to generate codecs to serialize and deserialize your stuff, it gets in the way. It doesn't present the way that like a normal class would. And so there's some special handling that you have to do sometimes to account for things that aren't quite standard. The code all works, of course, but like resolving what can, I had a bug request, and it's like, can you do this, add this so I can use Lombok and annotate, blah, blah, blah. And I was like, no, it complicates my stuff for almost no value. But so Lombok is fine. It just, if you do a lot of reflection, it can get in the way in some surprising ways sometimes. But I have a bunch of friends that use it and love it, so I'm being a little facetious when I say don't use it, but really you shouldn't use it. So, and then you had a question.
Just a quick question. When you're generating source code, what are the pros and cons of committing it or not committing it? Or should you always commit it?
The question, in case you couldn't hear it all, is like, what are the pros and cons of committing the generated source code or not? I don't, because it's a little bit like committing your class files, right? Like, people have done it, but it's not the normal practice because it's something that gets generated at build time. And it's not only does it get generated at build time, so if you clean and compile it, it comes back. If you start shoving all that stuff into your Git repository, now suddenly you have all that history in there as well. And it's useless because the history of that particular source file is largely meaningless because the real context and real interesting tidbits about what changed are off in the generator side of the world. And its output is a little bit less interesting from a historical perspective. Yeah. Anyone else? I thought I saw a hand come up.
You haven't talked so much about the input to the code generation. What do you usually do? What type of scenarios do you have when you...
What sorts of inputs do you have to code generation? That can really vary. Like, for example, I mentioned OpenAPI earlier, and that's like a JSON file, YAML file, something like that. So it varies. For my personal project on Morphia and Hibernate the same way, the input is actually your own class files. So I will look, well, that's not entirely true. For my stuff, I actually look at your source because why not? Hibernate looks at the class files. So it kind of depends on, it can be whatever you need it to be. So for example, in my critter project, I'll look at your source file and I will build some metadata about your entity, and then I use that as the input for my generator to figure out, like, do I need this annotation, do I need this class, whatnot. But it really depends. It can be anything you want it to be. It can be an XML file, it can be a PDF, CSV, kind of depends what you're doing. Did I see? Yes. You have 5 seconds.
Yeah, can we use the DDLs for this code generation, database DDLs, if we have a schema or give a schema definition?
Sorry, that was really loud. I'm sorry. Could you repeat that?
Yeah, can we use the DDLs or like schema definition, like database? We have this RDBMS schema with a set of tables, and I want to generate classes for the
Oh, right.
tables.
Can you, was it Artemis? Was that what you said? Yes, you can use, like I said, you can use almost anything you want as an input. You just have to have something to read that input into a meaningful model for your code generator then to work off of. So, I mean, there's like PDF box, for example, if you needed to use a PDF file as a input of some sort. You could use whatever library you need to get some sort of in-memory model of what that file looks like on disk. And then from there, it's, whatever your imagination can do with it. So, yeah.
Thank you, Justin.
Yep.